Let's now talk about another problem, the eternity puzzle. And you will see you will implement it as an exercise. So, what is the eternity puzzle? The eternity puzzle is an edge matching puzzle where you have tiles that you have to place on a board, and each of the tiles need to have matching borders with the tiles next to it. So you need to find a way to fill all the board with all the tiles matching the neighbors, the adjacent edges that they have. And the initial puzzle is a 16 times 16 grid, and you can learn more about it on the Wikipedia page. So, how are we going to model this? First, when we model something, we need the variables. So, the variables will be what color will we have on each of the tile of the board. So, what will be directly on the board. For this, we will have one variable for each of the color, because each of the tiles have 4 colors, but also one for the ID of the pieces that we will put on this tile of the board. So we will have Y1, Y2, Y3, and Y4, which will represent the colors, and I, which will be the ID of the piece that we will put there. But now, how can we model the fact that we have a given piece and we want this piece, this actual piece, to correspond to the variables that we have? So how can we model an actual piece into the variables? Well, we can do it with a table. How can we do it? Well, we will assign values for each of the color. So, for example, this one is color 1, this one is color 2, this one 3 and 4. And we will have one line of the table which will match so the variables for each of the color in the board and the ID. And so our piece here, we have color 1 for the variable here up, the right one is 2, bottom one is 3, and left one is 4. So we have here our line. And this piece is ID 14, for example. So we have ID 14. But the problem is we can rotate these pieces. So we also need to have one line per rotation. So here we have rotated the piece. So now color 2 here is up. So we need to fill a new line with color 2 as up, color 3 as right, color 4 as bottom, and color 1 as left. And it's still the same piece, so it's still ID 14. And we also need to do next rotation, where this color is up, this one is right, this one bottom, this one left. And last but not least, last rotation, where we have the last rotation. And so with these 4 lines, we can model each of the rotation of a given piece. So this is how we model one piece. But then, how do we model all the pieces? Well, we can have a table with all the line for all the pieces, an aggregation of all the pieces. So here, it's the table for one piece, the piece 9, and all of its rotation. And here, it's the line corresponding to piece number 6 with all of its rotation. And so on. You add all of the elements. And now that we have our table with all the pieces, we can also model the whole grid and not only one of the square. So to model the whole grid, well, we can model each of the square individually, but we can see that 2 squares, they share the same color when they are neighbors. So instead of having 2 variables and linking them with an equality constraint, we can directly use the same variable for both. So this is why each time we have neighbor edges, we will use the same variable. this is valid for here, but also here, 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 here. And we have each time for each of the squares all the IDs for each of the tiles that will be put on the board. Okay, now we have our variables. We have a table which will model all the real pieces that we need to place. Let's now look at the whole model of the eternity puzzle. So, we know that for each position, each of the squares, we need a valid piece to be put there. So, we will model this using a table constraint, which will say, okay, the variable that corresponds to one of these squares should be part of a table containing all the possible pieces that we have. But we also have another constraint, which is we have only one of each of the pieces. So we can't put twice the same values. We can't put one and the other one which is the same but a rotation of it. No, we can't put that. So how can we do that? Well, we can add a null different constraint between all the IDs that will be put on each of the squares. By using the all different, we will ensure that each piece selected will be with a different ID. So only one of the rotation of a given piece can be selected on only one square. And now we have our model and we can solve the eternity puzzle. And now it's your job to do it.